Project Euler Problem 1. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below 1000. Let's make sure we understand the problem statement. List all the numbers below 10. Pick out the multiples of 3. Then pick out the multiples of 5. We get 3, 5, 6, and 9. Let's sum them up. And we get 23. Now we just need to do the same thing for all natural numbers below 1000. As a programmer, how would we begin? How about doing this in Python? We could begin with a for loop. To take a look at each number below 1000. Check if that number is a multiple of 3 or 5, and create a variable to track our total sum. And finally, print it out. We get 233,168. I did note I can do this without a for loop, so let's take a look at how we could approach that solution. How about we begin by simplifying the problem? Sum all the numbers below 100. Essentially, this equation would represent what we want to do. Would you agree that the equation below is also another way to represent what we want? Now what would happen if we added these two equations? Did something interesting just happen? Now, how many 100s do we have? I count 99 100s. Let's divide by 2. 99 times 50 is 4,950. Please feel free to double check my math. Next, let's work on generalizing what we have. Starting with our first equation, replace our numbers with variables. Where A is our sequence of numbers, A1 is the first number in the sequence, and A sub n is the last number in our sequence. We'll do the same for our second equivalent equation. Add them up. And since every term is equal to every term, we can pick any term to be our multiple. Multiply it by the number of terms we have, which is n. Divide by 2. And we have our general equation for summing our sequence of numbers without a for loop. Here's a bonus for the mathematicians since we just went over the proof. Now we can increase the complexity of our problem and find the sum of all the multiples of 3 below 100. We can represent this problem statement with this equation and start our journey over. How about I propose a fork? Let's do something different. Since we have multiples of 3, could I just factor out a 3? Isn't that an interesting sequence of numbers? Let's rewrite this equation into this form because it'll make the math easier later. Let's bring back our summation formula for reference. Hopefully it's clear that we can apply our formula to these portions of the equation. Let's start by identifying our variables. Here is our a1. Here is our a sub n. Our multiple is 3. Let's generalize that to m. There is something unique with the very first 3. It's our multiple and will always be our multiple, which allows us to simplify m over m to 1. Now, the hard part. How do we get this 99? We can say it's a given from our problem statement, or we can compute it given an arbitrary maximum. I like the second option. How do we find the largest multiple of 3 below 100? How about we start by dividing 100 by 3? This will give us a repeating number. Let's floor that to get rid of our decimals. Finally, multiply by our multiple and we get our 99. Let's turn the 100 and 3 into variables. Substitute our 99. Let's simplify. Now, to update our summation formula, bring down our m. a1 is equal to 1. A sub n is our floored max over m. Finally, n is just our a sub nth term representing how many terms we have, which is our floored max over m. And hopefully that's it. Let's test it out. Our max is 100. Our m is 3. 100 divided by 3 is 3.3 repeating. 3.3 repeating floored is 33. 1 plus 33 is 34. 3 times 33 is 99. 34 divided by 2 is 17. 99 times 17 is 1,683. We can verify this result by letting Python count the sum of all the multiples of 3 below 100 for us. And we would get the same result. Let's bring back our original problem statement. Let's break it down into manageable steps. Let's bring in our last equation. We'll use this equation for multiples of 3. And we'll use this equation for multiples of 5. A quick review, the equation above will sum all the multiples of 3, such as 3, 6, 9, 12, 15, and 18. The equation below will sum all the multiples of 5, such as 5, 10, 15, and 20. Uh-oh. Do you see a problem? We have duplicates. We need to get rid of one set of these duplicates. How about we just subtract them out using the formula we have in front of us? The screen is starting to get crowded. Let's consolidate. Much better. Let's code this up. Let's start by defining our max. Reminder, we're looking for multiples below 1,000. Now let's define a function f that takes one parameter, m. Let's perform that floor operation once and store it into a temporary variable. Finish out the rest of the function. Call our function with our desired multiples and remove our undesired multiples. And finally, print it out. Let's bring back our first program for comparison. And that is Project Euler Problem 1, without a for loop and with a runtime of big O of 1. Thanks for watching.